Hello everyone. Today I talk about our 6 year small CubeSat. The title is Let's Receive the Signal from the World's Smallest Moon Lander, OMOTENASHI. So let me begin. I will introduce myself briefly. I'm working in JAXA and developing the communication system mainly. Yes, so mainly my interest is in CubeSat. Now I'm working on OMOTENASHI, Eclair's, Stream, and others. OMOTENASHI and Eclair's is 6 CubeSat and launched by the same rocket. Stream is the middle class satellite in JAXA. Besides, I'm the director of the JAXA Ham Radio Club. This club is composed of some JAXA and Wakayama University members. OMOTENASHI has a UHF communication system, so we need an amateur ham license to operate. Many of the members are amateur first-class radio operators, also me. Today, I want to talk about the UHF communication system of OMOTENASHI, but first of all, we have to know what is OMOTENASHI and its mission. OMOTENASHI is a 60 CubeSat, and its primary mission is to verify the developed technologies about the world's smallest moon lander. If we succeed, this is the first moon lander from Japan. It will go to space by the most powerful rocket NASA developed. In the right side figure shows. Yes, NASA developing the space launch system. So we call this SLS, Space Launch System. See this picture. This figure, this part is the stage for setting Orion and has 30 dispensers to equip 6 CubeSat. This black component can contain CubeSat. OMOTENASHI also will be set on. NASA scheduled the launch date for February 2022, so we are planning to open OMOTENASHI now. However, the launch date is not fixed because there is a possibility they will postpone the date as the rocket condition. We are working on assumptions that the launch will be in February, but however, according to the NASA blog last Friday, the launch will be in March or April. In this case, launch date will be postponed until March, April, or more later. I don't know. Please wait for the information from NASA. Next, let's see the inside of OMOTENASHI. OMOTENASHI comprises 3 parts: orbiting module, surface probe, and solid rocket motor. The function of orbiting module is to bring surface probe and solid rocket motor to the lunar impact orbit. And the unique characteristic of OMOTENASHI is that it has a solid rocket motor inside. Yes, this one, the cylindrical component. This is the rocket solid motor, a solid rocket motor. We have to design this solid rocket motor to decelerate the moon lander on the landing phase. So we put it vertically through the interior and arrange other components on either side, such as transponder, dosimeter, RCS, RCS control unit. Okay, at last, the third component, the square box here. Square box on the head of the rocket motor. This is the moon lander. We call surface probe. Surface probe has a contained device in it. As OMOTENASHI has no soft landing mechanism such as legs or parachute, so the light and tiny components only can land and survive on the moon. Then, yes, I talk about my work. I developed a communication system for orbiting module and surface probe. This picture, this figure shows the orbiting module's communication transponder. About orbiting module, an ultra-compact transponder can transmit and receive the X and UHF band. The size of this is 8 centimeters square, and the thickness is about 6 centimeters. It consumes about 12 watt to transmit 1 watt on X band. And then the right side here. This picture shows the surface probe. Surface probe has only a UHF transmitter and a foldable circular polarized antenna. Using these components, how does the OMOTENASHI landing on the moon? Okay, look at the following diagram. And now, 1 hour ago, I get this tiny OMOTENASHI from my 3D printer. So I explain using this story. Yes. After SLS eject OMOTENASHI, at first, we stabilize the attitude of satellite and direct the sun array panel to the sun. On the landing phase, OMOTENASHI spins up around Z-axis. This is Z-axis for stabilizing its posture before firing the solid motor. The solid motor is powerful but so tiny that it can only decelerate SP, not orbiting module. Therefore, the solid motor and SP escape from the orbiting module like this. And orbiting module will not decelerate it, so fly to the moon, hitting and destroyed. Solid motor decelerated SP. So these two components land on the moon with 50 meters per second. As a restriction from the 6th CubeSat, only a 0.7 kilogram SP device unit can land and survive on the moon. As this flow shows, this is not a soft landing. We call this semi-hard landing. Based on the result of the impact test at Tsukuba in Japan, SP can survive up to 10,000 G. Then I talk about UHF communication system finally. At first, yes, green area from orbiting module. It transmits beacon or fixed length message via PSK31 modulation. Orbiting modulation also has a receiver. So we try to send several messages to OMOTENASHI from the ground station at Wakayama in Japan. Yes. Next, I talk about SP, blue area. It has an accelerometer inside and can transmit the acceleration data, analog data with FM modulation or digital telemetry data. The digital format is PCM, PSKPM, and it may be 32 PPS, but the most interesting transmission format is analog FM modulation. So I explain about this later. The mission of OMOTENASHI finished if we succeed in firing the rocket motor and the OMOTENASHI flies to the moon. However, the acceleration data is worth recording because it explains how the lander meets the moon. And the amateur ham enthusiast only can get this data from the moon. Why? SP has only a UHF band transmitter. Would you like to try a reception experiment with us? Then I explain how to send analog acceleration data with FM modulation. Here, the measurable range of the equipped accelerometer in SP is 10,000 G. We convert it linearly to the transmission at frequency. So if the measured acceleration varies, the carrier gets higher or lower in the 14 kilohertz bandwidth. We assign a carrier to each of the 3 axes, so the observed auto-starting signals are 3. This figure is a screenshot of the spectrum analyzer when developing the electronics model. We assigned X, Y, Z axis from left to right. As SP has no receiver, it automatically switched from FM modulation to PCM, PSKPM. Okay. And this slide explains the UHF antennas of orbiting module and surface probe. The left side is OM antenna, and the right side is SP antenna. First, see about orbiting module. We could not mount an ISM or pop-out antenna from the restriction of structure. Therefore, we designed the split ring resonator antenna at 437 megahertz. The VSWR is low enough, and however, the max gain is minus 80 dBi or too small, thus the link budget is so thin. Okay, then right side about SP, surface probe. I designed the circularly polarized system using invert F antennas. We have to store SP in a limit area of orbiting module, so this antenna is foldable, like origami. However, the first delivered FPC is so thick, about 35 micrometer. I thought the maker who can build the thinner or thinner and thinner. Finally, we could put the whole SP into the orbiting module like this. Yes, this is the SP antenna. Here, I show you the link budget. The left is for orbiting module and the right is for surface probe. From the orbiting module, the carrier noise ratio of beacon is 30 dB, so that you may receive it more accessible than PSK31. To receive PSK31, we need a powerful receive antenna. About SP, as the antenna gain is 1 dB, I expect that we could receive a strong signal. We try to find this signal and receive a spectrum with a 100 kHz bandwidth. This data would tell us the impact when the SP meets the moon. We are preparing the ground station with Wakaima University, and Wakaima Uni has 30-meter antenna for EME, but there is a significant problem. There is a possibility we have no eye from Japan on the landing phase, depends on the launch day. I'm looking for some enthusiasts who can cooperate with this receive experiment. Through the ARRL newsletter, some radio station contact us. Thank you very much. And if you or your friends have the radio station, let's receive the whisper from the moon with us. I love Star Wars, so many of you will also know the scene of episode 4, this. We need our Obi-Wan Kenobi. I think the receive experiment from the Japanese first moon lander is so exciting. I'm waiting for your cooperation. Thank you for your listening. I show our contact details here. Please feel like to contact us. Write English, or of course, Japanese. Thank you.
Thank you very much, Torii Sensei. I agree, it's very exciting. I was just thinking perhaps you could put the link for your contact in the chat, and then that way people can reach you a little bit easier. I'd like to just open the floor now to participants. If you have questions for Torii Sensei, please go ahead and ask.
May I have one question?
Sure, go for it.
Okay, it's an exciting program. I really appreciate that you shared with us your plans. My question is, since you are going to the moon, and it's not easy to accomplish all the technologies doing that, do you have some TRL levels, as the NASA says, some flight experience with your technology you are using on your experiment right now?
Landing technology about question?
Yeah, I think the question was about whether you have like any flight experience with some of the technologies that you're using, particularly maybe by the solid rocket motor, for instance, maybe, Rainer, is that what you're hinting at?
Solid rocket motor and the communication part.
Oh, I'm not good at also listening English. So if I wrong answer, please contact me. The landing technology is SP has not only solid rocket motor, but also it has crushable material so behind it. So it absorbs the shock on the landing phase by the crushable material, and solid molecular deaccelerated SP. And SP's antenna has 4 circularly antennas, but 4 elements. If any element died, one element has survived, we can transmit vertical or horizontal polarized radio waves. So we preparing the vertical or horizontal antenna simultaneously records the radio waves. This is the answer for your question.
I'm Tatsuaki Hashimoto, project manager of this OMOTENASHI project. I'll answer about the TRL. That is a very difficult question because all components is not, how can I say, flight experience. Of course, we are newly developed, but the technology itself is some heritage. And we, of course, tested on ground, flight level test, vibration test, of course, thermal vacuum test, or other kind of many tests. So TR level will be about 5 or 6, I think, I believe. Yeah, but each, for example, communication system itself is a newly developed one, but that has used heritage of a Procyon mission that is launched in I forgot the year, but several years ago, and flight proven, and that is using that technology, we miniaturize more and more like that. And in case of a solid rocket motor, that is not used in space, but on ground, similar technology is used for military. That is, I heard it was made 10,000 such kind of parts. So TRL, we are very difficult to say, but yeah, that is the situation.
Excellent. Thank you for your explanation, Hashimoto Sensei, and Torii Sensei for your presentation.